Welcome to 4Keys online tutorials. In this video we'll talk about alcohols and carboxylic acid. So you should understand that alcohols are a homologous series group of molecules that contain the OH functional group. So these alcohols are very similar to alkanes. You can think of alcohols as alkanes with one of the hydrogens replaced with an OH group. So you're going to see that these groups are very similar. And you can see that our carbons are also saturated. We do not have double bonds for most of the alcohols that you're going to be studying in O level. So let's look at the first four members of this homologous series group. We have our methanol, ethanol, propanol, and butanol. So you end the name of an alcohol with an OL. Okay, let's look at the general formula there, CnH2n plus 1 OH. So if you still remember, for alkanes it was CnH2n plus 2. So one of the hydrogens there has been removed. So we have H2n plus 1. And then we'll put an OH at the end. So like I said, this is similar to replacing one of the hydrogens with an OH. So remember, the OH is put at the end to show that it's an alcohol. Alcohols have, the first four alcohols, they have similar properties, but just like any other homologous series groups, you're going to realize that the properties change with increase in the number of carbons or length of the carbon chain. So there are general properties here that we are going to look at, which are that the alcohols are flammable, they are soluble in water, and they also can be oxidized to carboxylic acid. So when we say they are flammable, we simply mean they can burn to produce a lot of heat in complete combustion, as shown there. So what you simply have to do, as we have shown in another video, is that you balance the equation just like any other equation. So these molecules will burn to produce for you carbon dioxide and water, and you have to balance the equation. When we say they are soluble, they can dissolve in water to form solutions. And remember, these are miscible with water. We also use that term to describe the fact that they are very soluble. They are miscible with water. And then lastly, they can be oxidized to carboxylic acids. So what are carboxylic acids? We'll look at that in greater detail, but they contain that functional group highlighted there. That would be your carboxylic acid group. Some uses of alcohols that you're supposed to be familiar with is that they're used as fuels. They're also used as solvents in industry. Okay, so let's look at carboxylic acids in greater detail. Carboxylic acids are also a homologous series group, and they contain the functional group COOH, which is written C double bond O, and then C bonded to that OH group. So you have a double bond between carbon and oxygen, and a single bond between your carbon and the OH group. So this is a homologous series, just like any other series that we've looked at. So those are the first four members. So the names end with ethanoic acid. So if we have one carbon, that would be ethanoic acid. When we have two carbons, when we have one carbon, that would be methanoic acid. Two carbons, ethanoic acid, propanoic acid, butanoic acid. And when you're writing the formulas, you need to show the C double OH group at the end of the molecule. This is to show that it's a carboxylic acid molecule. So that is how you write the formula. Okay, so these carboxylic acids react just like any other acid, but they are weak acids, meaning that they do not fully ionize when they are dissolved in water. Ionization of an alcohol here is referring to the fact that it will split into a negatively charged ion and some hydrogen ions. So carboxylic acids, or any other acid for that matter, will donate for you your H plus ions. So here we're going to form a propanoate ion, and some hydrogen ions. So let me also show here what we mean. If you had sulfuric acid H2SO4, sulfuric acid will ionize to give you 2 hydrogen ions and your sulfate ions. Sulfuric acid is a very strong acid, so it will fully ionize, meaning that a large number of the sulfuric acid molecules, when they are put in solution, they are going to break to give you these 2 ions. So for the weak acids, a large number of the acid molecules will remain intact and they will not break to give you your cation and anion. So weak acids do not easily donate their protons. They do not fully dissociate when they are put into solution compared to our strong acids, the sulfuric acids, nitric acid, hydrochloric acid. Okay, so that's also very important. Then these carboxylic acids can react with a metal to give a salt, water, and carbon dioxide. If you react the carboxylic acid with a metal carbonate, you're going to get your salt, water, and carbon dioxide as shown there. For example, our ethanoic acid will react with potassium carbonate to give potassium ethanoate, water, and carbon dioxide. Okay, so that's it about carboxylic acids, which is a homologous series on its own. And remember that you can form carboxylic acids by simply oxidizing your alcohols. And alcohols are easily oxidized to carboxylic acids. So I'll meet you in another video where we will talk about other things that are important in your study of O-level organic chemistry.